And we're recording. All right. So we're going to start the statistics unit today. We're not going to finish section 20.1, but we are going to put a significant dent in it. And it's going to basically begin with vocabulary, important vocabulary when we're talking about statistics, okay? So we just have some basic statistics vocabulary. Don't worry, there's no vocabulary quiz or test or anything like that, but you do need to know what we're talking about when you use these terms, and I ask that you use your academic vocabulary as well. So a population is an entire collection of individuals that you're trying to draw conclusions about. So say I polled, for Gavin, say I polled Sarasota County about what their thoughts about the president were, and then tried to use that information to make a conclusion about the state of Florida. See, the state of Florida would be our population, whereas whereas Sarasota County would have been something smaller. It's a sample. See? So this is what statistics tries to do. It attempts to take small pieces of data and use it to make assumptions about larger pieces of data. So a census would be the collection of the information from the whole population, like I said, about the president. Now, this year was a census year. That means they attempted to get in touch with every single American that they could, because that would have been the whole population. A sample, like I've already said, this is a small piece of the population. It should be chosen at random, and that is important. It must be random to avoid bias in the results. For example, the last thing I would do is go into a Starbucks and do a survey on who likes coffee, because that is not random. It is biased, right? Okay. Oh, speaking of the word survey, it is a collection of information from a sample. How about that? Data is information about individuals in a population. So a categorical variable. It's going to describe a particular quality or characteristic which can be divided into other categories. Whereas a numerical variable is going to be describing a characteristic which has numerical value, something that can be counted or measured, quantified in some way. For example, I could do a survey on how many people in our school have blonde hair. Or I could do a survey on the average lengths of blonde hair. These are both considered numerical. But if I was just talking about what color hair do people have, this is categorical now, because we have blonde, we have brown, we have brunette, we have black, we have red, and so on and so forth. You see, that can't be measured or quantified. How many of those people can be quantified, but the variable is categorical. Where if I'm talking about the lengths, that is a numerical variable. A parameter would be a numerical quantity measuring some aspect of a population, where, as I said, the length would be the parameter of my survey. And a statistic is a quantity calculated from data gathered from a sample, usually used to estimate population parameter. For example, if I wanted to take information about the people in Sarasota County, voters in Sarasota County, are we pro-Trump or pro-Biden, and let's just say that we got a 51% Trump support, then I would attempt to use that statistic to say that, well, the whole state is 51% Trump, okay? Distribution are the patterns, the way the data falls. It's a pattern of variation of data which may be described as three different things usually. Now, this first one is called symmetrical for obvious reasons. It can easily be split in half, right? So it's symmetrical. This is what you call a standard bell curve. And I think hopefully we've all heard of that term, bell curve. The one in the middle is positively skewed. Wait a second, Mr. M. That thing bumps up to the left. Why is it positively skewed? Well, for now, the best answer I can give you until we learn more about these things is because there's actually more data to the right of the middle than there is to the left of the middle. The spike is just where you found, like, how about a word you all know, the mode? It's just how many of that one thing there were. Yeah, this thing gets pretty tall over here, but if the median value or mean value or whatever middle I'm talking about would be somewhere around here, there's actually a lot more area under the curve to the right than there is to the left. So there is more data to the right. Therefore, it's called positively skewed. Yes? No. If it leans to the right, which is the last example, it's negatively skewed for the same reason, because there's a lot more area under the curve to the left of the line. So I know that the height is pretty tall to the right, but the area under the curve, which is a calculus thing, derivatives and all that stuff, which we'll do more of that in January, the area under the curve is greater to the left. So that's what makes that a negatively skewed. And outliers. Be really careful about the term outlier, okay? These are data values that are either much larger or much smaller than the general body of data. They should be included in an analysis unless they are a result of human error. So if you do a survey for your IA and you find a couple data values that are just wildly outside of all the other data values, you are not allowed to say, man, those are bad for my study. They're messing up my results. I'll throw them out. I'll call them outliers. Wrong, because they're not outliers if they're true pieces of data. You can't do that. That's cherry picking and that's biased, which is what a lot of the media outlets do. So you can't stand outside of a Republican voting center and say, are you pro-Trump or pro-Biden? And a lot of them like to do that. All of them, they're both guilty. This is how media works. So if you get real data values, you got to count them. If they were clearly a mistake, then you could say those were discounted because they were an error in recording. So numerical data values, there are two types in this course. You have discrete and you have, what's the other one? Continuous. Discrete would be things you can actually count. So if I said, how many people are in this class? I could count that, and there would be a whole number, I hope, right? A continuous one is one that does not have to be whole numbers, like hair length in this class. Those don't have to be whole numbers. Those are continuous. That means every decimal in between 0 and 1 and in between any other number you can imagine is a possibility. Sorry, I'm flipping through my crap here. There we go. So I want to make sure I write down exactly the definition that I want you to see. So a discrete numerical variable, takes exact number values and is often a result of counting. Takes exact number values and is a result of counting. Whereas continuous would be any type of measurement, weight, height, length, things that can be subdivided to smaller and smaller and smaller. We don't want to subdivide our human beings. That's scary, 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 right? So a continuous variable takes numerical values within a certain continuous range. Within a certain continuous range. And these are usually results of measuring. So I'm just going to write measurements. Okay. Frequency table. A frequency table is literally a table that tells you the frequency of something, meaning how often it occurred. A tally, it's like you're doing, you do the 1, 2, 3, 4, and then cross through it. Those are tally marks. A tally is used to count how many times a piece of data occurs. The frequency of a piece of data is the number of times it occurs. So the frequency is the number of times. The relative frequency means relative to some other number. So if I was talking about the percentage of people in the room that have blonde hair, that is relative to the number of people in the room. So that would be a relative frequency. It measures the percentage of the total number of data values that are in each group. And if you were in Algebra 2 Honors, you may or may not have learned those terms already. Just depends how fast the teacher was able to go. Now, my notes don't look like yours anymore because I printed new ones for you, so the back of mine is not necessarily the back of yours. Let me go grab a new packet. For the new textbook, new curriculum. Last year's seniors were using the old curriculum. So you guys are the first seniors with the new curriculum. Well, yeah, whatever. Yep. So, oh, next page. There we go. This is a frequency table that also has a relative frequency column on it. So you have your values 1, 2, 3, 4, 5, and then your tallies. And if you counted them, those would be your frequencies. Do you always have to use tallies? No, it's just important that you know how to read them. Okay. And if you added up all of these frequencies in this row, you would get 30. So to calculate the relative frequencies, you just do the frequency divided by the total. So you get this 26.7% by doing 8 divided by 30 times 100. So those are percent relative frequencies. Or you could just leave them as decimals without multiplying by 100. Completely up to you. Okay? Down below, we have two types of bar graphs that you are not allowed to say bar graph in your IA. It will hurt you. They're not bar graphs. These are, what do we call them? They are histograms. That's the word I was looking for. Now, a column graph is a little bit different from a frequency histogram in that column graphs, they don't touch. This is basically what you're talking about when you say a bar graph. You see, back in the day when you were doing your science projects for middle school and stuff, you know, when you got to make your tables, science fair stuff, yeah, and you go to Excel, and it's like, what kind of table do you want to make? And you could pick this one or this one, and sometimes you just pick the one on the right because it looks cool. But you're not allowed to. It's actually, sometimes it's bad. See, we use the one on the left for discrete data, things that can be counted where nothing's allowed to fall in between those values. We use the one on the right for data where, well, things could fall between them. And that's why the bar graphs touch. So there are no gaps anywhere in the data. That's the difference between the two. So frequency occurrence should be on your vertical axis. So that's where you're going to be, that's going to be your number of times it occurred for your discrete data, or the length or weight or height or mass of something for your continuous data. Yes, Bria? I don't want to say yes or no to that question. She wants to know if decimals automatically create continuous. I don't want to say yes to that, okay? Just know that if it was a measurement of something, which often includes decimals, it's going to be continuous data. If anytime that you can say something's a characteristic of it, instead of how many things it was. So if you're describing a characteristic of it, it should almost always be continuous. I would struggle to come up with a characteristic survey that was not continuous. The range of scores is going to be on the bottom, your horizontal axis. This is your range. Column widths are equal. You're not allowed to change the width of the columns to make the data fit the width thing you want. Who is calling you? You're not allowed to change the width of the column to make them look like the way you want. That is cheating. So, because it's cherry picking and biased. You can't do that. Now, can you alter the widths of all of the columns so that they're all the same width? Yes. But I can't say like, hey, you know what? I want to make this data, I want to stretch this way. No, you can't do that. You have to stretch all of them. You can't just do one. That's a big fat no-no. So don't do that. So column widths are equal, and the height represents the frequency, and the modal class. Now, that's probably a new term. You've heard of the mode, right? The mode is the category that has the most things in it, right? But if we were talking about lengths of hair, what are the chances that two people in the room have the exact same length? I mean, exact. Probably 0, right? So what we'd have to do is we'd have to say the modal class, the most common group, is between 6 inches and 12 inches of hair or something like that. And you can say that's the modal class, the most common group. It's easy to find from the highest column. Now, let's put this in terms of the distributions that we just saw a minute ago on the other screen. What, Alberto, you were concerned about the fact that the bar graphs, the curve graphs were spiking on what looked like the wrong side, right? Both of these are relatively symmetric distributions. relatively, right? But the height of the tallest part is nothing except for the most common column. That's all it is. So that's why the spike is going to what looks to be the wrong side. Because let's just say, let me draw one up real fast. Let's just say it looked like this. And my bar graphs, I forgot to draw straight down. Now this, you have to forgive I know it's not the same width, but that was an accident, but look. So that describes where it is, but if you were to add up all of the rectangles, there's more of them on the left. That means the sums, if you counted up these frequencies, this frequency plus this frequency plus this frequency plus this frequency would be more than these last two. So there is more data to the left of the mode, and that's why we say it's negatively skewed. Okay, so we got an example here, and unfortunately, the hardest part about this one is that our data is not ordered. It's random. Yeah, I tried to pick questions in the homework where the data was already ordered for you. I try, sometimes. A sample of 20 juvenile lobsters is randomly selected from a tank containing several hundred. Each lobster is measured for length. So this is a measurement. That means we're talking about continuous data. Look, decimals. Decimals didn't mean it had to be continuous, but they're a good predictor, right? And here are the results. It says organize the data using a frequency table and hence, everybody's favorite word, graph the data. So rather than actually order the data, let's just create our widths, our classes. Let's separate it into classes. And I separated it into classes of length 1. Well, the smallest value up there is 3.1. So here is my data table. Okay. Length, the smallest one was 3.1. So I'm going to say my lengths can be between 3 and 4. And then from 4 to 5, so on and so forth. 4 to 5. 5 to 6, and took it all the way to 8. My table is going to be large. Because the largest number on here is south of 8, right? 7.2 is the largest one. He wants to know why there's not an or equal to on the right side.
Well, I understand it was like the 8, but I don't understand why.
Right. So again, you notice all the left sides have the or equal to bars?
Yeah.
That's because if you put an equal to bar on both of them, then someone who had exactly length 4 falls into 2 different modal classes. Think of my IB grade curve. Remember how the sides, one side's a parenthesis and the other side's a bracket? Think of these are the parentheses in the bracket. I got an 85. Does that round up? Like, I go, well, so someone who got an 85 and someone who got an 85.1? They go, I'm sorry. If I put a bracket on the 85, you're not getting the same score as someone who got an 85.1. That's just the way that works. So if I put, let's just say I did this. Now a 4 lands in 2 different categories, and that doesn't make any sense. You have to be one category or the other. So what you do is you pick a side to put the equal to bar on, either all on the left or all on the right, and it doesn't matter which one. We just went with the left because why not? Like, because they're continuous data. Yeah, because it could be any number. Remember, because this is a sample, and you're trying to make predictions about the population. The frequency, I'll count them up for you. 3 of this one, 6 of this one, 5, 4, 2. Save you the time. That's what you would have gotten had you counted them. So So here is your frequency table of your continuous data. It looks like that. Ta-da. Okay? And then it says graph the data. Before I do that, I'm going to go to B, because it says state the modal class. So which is the most common class? 4 to 5. There you go. That's the most common class. Now my left-hand symbol got a little sloppy. Sorry. I'll be honest with you, the tip is dirty, and it squeaked and gave me goosebumps, and it messed up my handwriting. So it screwed me up. It was bad. I need to clean it or switch it. So that's the modal class. Let's go ahead and graph the data, because that's what part A told us to do. We didn't finish doing that yet. So here's our graph. Vertical one is the frequency. Horizontal one, I said horizontal one, not diagonal one. Horizontal one is your range of values. So we go 3, 4, 5, 6, 7, 8. I'm not going to bother with 1 and 2. I'm just going to start at 3 and go to 8, because we don't have any values at 1 and 2. So let's just say this one's 3. Picture not drawn to scale, because nothing happens to the left of 3, so we don't care. And our frequencies go from, well, the highest frequency is 6, and the lowest possible frequency ever is 0. So we're going to go from 0 to 6. So 1, 2, 3, 4, 5, 6. And we are going to draw bars on our histogram. So if you fell between 3 and 4, there was 3 of them. Between 4 and 5, ooh, 6 of them. Between 5 and 6, there's 5. 6 to 7, there's 4. And 7 to 8, there's 2. I did my best to be scale. Part C says to describe the distribution. So if you had to draw this, it would look like that. It does bump slightly to the left, like Gavin so eloquently shouted out, which would make it positively skewed. So there's a positive skew there. Okay. Making sense so far? No, remember, just because the notes are easy and the homework is easy does not mean that you don't have to have a deep understanding of what it all means. Me. So we can get a good understanding of data if we can find the middle, aka the center, of the data. This will also give you an indication of its spread, also known as dispersion, but we're just going to say spread. So this also gives an indication of the spread, which literally means how spread out is the data. That's what that means. There are 3 statistics: mean, median, and mode. I think you've been working on mean, median, mode since 6th grade math, maybe. The mode for discrete data is the most frequent value. And for continuous data, it's going to be the class that has the most things in it. So let's be more eloquent. Yeah. And what we're going to say is we're going to use the modal class because no two values have to be the same. This is the class with most things in it. Whoop, not int, in it. No two have to be the same. So, whoa. No two have to be equal. I hate having to write so big. No two have to be equal. And the mean is just a fancy way of saying the average. And finding the mean is the same as the way it's always been. It's literally the sum of all data values over the number of data values. Meaning, how many blonde people were there divided by the total number of people there were. The sum of the data values, the ones you're trying to look at, sum of values divided by number of total values. Oh gosh, this thing is squeaking like crazy. It's driving me nuts. And what's neat about the mean is that it doesn't actually have to be a member of the data set. You're going to see in the very near future that the average roll on a die is like 3.6. So like rolling a die and finding the average over millions and millions of tries, the average is something like 3.6, which is impossible, but it's still the average. You'll see. You'll see. We will learn. We will learn. So let's say that fancy x, which is the variable we're going to use, is a numerical variable. X sub I then is the ith data value. Think back to infinite series, like the u sub 1, u sub 2, u sub 3. It just meant the second, third, and fourth item. So if we're letting fancy I mean the fancy x, is our variable, then x sub 1 is the first time that happened, x sub 2 is the second time that happened, so on and so forth. N would be the number of data values in the sample population. So if ever you're reading something, I don't know, I'm kind of nerdy, so I go to the science subreddit, and I'll look up a neat study, and one of the very first things I look for is how many people were in the study. How large was N? And they always report that. It would be in parentheses. It'll say N equals 26. I see a number less than 100, and I think, well, I'm going to take that with a grain of salt. Because N equals 100 is one of the very first reliable numbers before you can really make predictions about the population as a whole. So if ever you see something looks fantastic, like, oh, look at that headline, and you start reading the study, figure out how many people were in the study before you go telling people about something that must be true. Because I've seen plenty of studies where they say something wild, and then you look and it's like, oh, there was only 9 people in the study. Like, okay, maybe they were special. And we're going to call this X bar with this X with a straight bar over the top of it. That is not segment X. Let go of it. It's not a geometry thing. Wow, he just threw a smashed apple or orange all over the floor. Anyway, X bar is the mean of a sample. That means you add up all of the iterations of X and you divide by the total number of X's. So that would be X1 plus X2 plus X3 plus ... plus all the way out to X sub N. And let's just pretend there was 20 of those X's, then you would have divided by 20, which means you're dividing by N. So X bar is the mean of a sample. Well, we're going to start to use sigma notation again. Remember we used it all the way back in Unit 6 and 7? Right. So instead of saying x1 plus x2 plus x3 plus yada, 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 we're going to add up all the x's from the first one to the last one. So we say sigma I equals 1 to n of x sub I. That means add up all the x's starting at 1 and ending at n, and then divide by n. That's just a fancier way of seeing it. So X bar is the mean of a sample. It squeaks. I can't do it nice because it squeaks. Yeah, I know. I can't do it nice because it squeaks. Now this one here, this next one, this next variable, for my physics students, you recognize this variable? It's a mu. It's a Greek M. Mu. Yeah, it looks like it's a mu. Okay. So the mean of a population is mu. Mean of a sample is X bar. Mean of a population is mu. And mu would be basically the same thing. It would be this and this. Because you don't have a choice. If you are using a sample to make a prediction about the population, you must assume that the mean of the sample is relatively equal to the mean of the population. That's the whole point. Now again, if I walked into a Starbucks and I started taking a survey on how many people like coffee, it wouldn't matter how many people were in that survey, I would never be able to use that mean to predict the average number of Americans that like coffee. That doesn't work because it wasn't a biased survey. But if I stood at the front of Walmart and as people walked through the door and I just like, do you like coffee? You see, this is a random sample. It has nothing to do with where I'm standing. And if my sample size is large enough, then I could say the mean of that sample should be relatively equal to the mean of the population. Okay? So that's what it says. In most cases, you don't have data from a whole population, so X bar is an approximation from mu. So we've done mean, we've done mode, now we just need to talk about the median. The median is the middle value. It's the value in your survey that's in the dead middle of all the values. The middle value of an ordered set. They must be in order, though. Middle value. So this one has to be a part of the data set of an ordered data set. So I roll a die millions of times. And the number of times it lands on 1 is equal to the number of times it lands on 2, equal to the number of times it lands on 3, 4, 5, and 6. The value in the dead middle must be one of the numbers in the sample. But the mean of those numbers does not have to be in the sample. So if there is an even number of data points, the median is the average of the two middle values. Which does not have to be part of the data set. Nope. And that happens a lot. Like say you order a data set and, like I say, there's an even number. So what you do is you take the two in the dead middle and just find their average. That clearly is not a part of the data set, but it would still be considered the median. And I feel like that is a good place for us to stop the notes for today.